Hey guys, welcome back to another video. Today I'm going to be going over minimum size subarray sum. This is a part of my raw and authentic LeetCode walkthroughs playlist. And essentially I haven't done this problem yet and I'm just going to work through this problem. So this problem is a medium problem. Given an array of positive integers nums, and a positive target, 7 in this case, return the minimal length of a subarray whose sum is greater than or equal to the target. If there is no such subarray, return 0 instead. Okay, so let's think about this one. So since it's a subarray, and we know that subarrays are contiguous, we can then say that it's probably a sliding window problem. So what will happen is, you look at the first number, it's a 2, that's less than 7, we're not going to care about that. Then we add the next term, 5, that's still less than 7, we're not going to care about that either. Then we're going to look at this, we have 6. 6 is still less than 7, so we don't care. Now, however, we have 8. 8 is greater than or equal to the target, which is 7. So now we're going to record 4. Okay, 4 is our answer so far, okay? Then what we're going to do is, since we have 8 now, we want the smallest length of a subarray, so we're going to try to cut it now from the other side. So we're going to cut this side off, and now we have 3, 1, and 2, which is 6. So this, again, does not work. So now we add another term from the right. So now here we have 3, 1, 2, and 4. That's 10. That's greater than the target again. And the length here is still 4, but so this, at this point, we have a 4 here, and the length here is also 4. So we're just going to leave it at 4. And now, since this is greater, we're once again going to remove the leftmost term, and now we're going to have this. And this is 7 on the dot, and the length here is 3. So we're going to replace the 4 here with 3, since we're trying to find the minimal length of a subarray. So now we have this, and that's 7. Now, since this is greater than or equal to, we'll try to cut down the last term, because maybe this is a 0, maybe this is a 0. So in that case, we could maybe try cutting it off, and then we'd have 7, but unfortunately this is a 1. So this is now 6. And since this is 6, this is less than the target, it doesn't matter, so we're just going to add another term. And now here we have 9. So 9 is greater than the target. The length of it is 3, but we already have a 3 set for the output, so we're just not going to do anything there. And then we remove the last term there. We get 4 and 3. That length is, so that adds up to 7, which is the target. This is the answer, I'm pretty sure. Yeah, the subarray 4, 3 has the minimal length under the problem constraint. So 4 and 3 add up to 7, and the length of that is 2. So now this is 3, we're going to replace it with 2 now, okay? And then after that, since it's equal to 7, we'll remove the 4 and we'll get 3. And then 3 is 1, but it's under the target, so we're going to ignore that. And then our final answer is this subarray, which is a length of 2. So here there's a few things that you have to pay attention to. So there is going to be a minimum length that we look at. So for instance, when we got here, we had 4. So eventually we had to compare that to this, and this also, sorry, we had to compare it to this as well, and this also has a length of 4. So we just took either one and ran with that, and then here we had a length of 3. So we have to be able to compare the 3 with the previous scene 4, and then we have to say, the 3's less, so we're gonna choose 3. So we need a variable that's like min length, okay? And I'm gonna set this to, this is gonna be, so if there is no such subarray, return 0. So I need like a pretty specific value for this, because if this doesn't change, that means there's no subarray. And if there's no subarray, then we return 0. So I'm gonna say it has to also be a very large number, because then no subarray in the test cases can be greater than it. So I'm gonna say infinity, actually. So we'll say float infinity in a string, and that just basically means the minimum length is infinity. And then at the very end we will say return 0 if min length equals to float. So basically if it doesn't change, otherwise we just return this. All right. Now, what do we have to think about? So we could do this with 2 pointers. We could have a left and a right and then just move them throughout the list. But an easier way to do it is we have the right progress from the left to the right, and then we have the left kind of trail behind it and move to the right if the value is greater than or equal to it, if that makes any sense. So for instance, right, if we have, like, if you want, you could do it how I just explained it, where we have 2 numbers and we just kind of add, and that's how the window moves. But say we had like a case where it was like, let's say we have a bunch of 1s and then we have a 6, and the target's still 7. So what'll happen here is you're going to have 1 added, then you're going to have 1 added, then eventually this is going to be your window, okay? And it's still not going to work. So you're going to add the last number, you're going to add the 6. Now imagine we had like a variable called like current sum or something like that, where we could see that this adds up to 12, and then we'd be like, okay, while this is greater than or equal to this, we're just going to keep cutting off numbers at the end, like a little, like a while loop inside of our function, if that makes any sense. And eventually we'd do it until here, and then we'd set this as our min length, and then since it's still equal to 7, we're still going to cut that off. But then we realize that 6 is less than 7, so we can't work with that anymore. So what I guess I will have now is I will have like a current sum, okay? And we're going to set this to 0. And then also I was saying that our left is going to trail behind and kind of pick up, like, remove numbers that kind of don't help to reduce the subarray. We're going to set L is 0, but we're not going to set R, because I have an idea of how we could do R in a way that is probably a bit more efficient. We could try it with 2. I bet that's like a pretty good way to do it. But one way you could do it is where you could just say for R in range length nums. Length nums. And then what you could say is you could say, okay, well, R is going to start at 0, and we probably want to add the numbers as we go. So we're going to start by saying the current sum, and we're going to add nums R. Okay. Okay, so now we've done this. Now we need to find a way where we can say that we keep removing the leftmost term until we can return what we need to. So what we could have is we could have a little while loop in here. So we'll say like while the current sum is greater than or equal to nums R, okay? Sorry, not nums R, target. Then what we will say is, okay, let's say for instance we are here, okay? Our current sum here is going to be 2. That's too little, so this is not going to matter. We're just going to go back through and we're going to add, we're going to add that. So then our sum is 3. That still doesn't work, so we're going to add it. Eventually we're going to get to here. Then what's going to happen is now our current sum is greater than our target, right? Our current sum is this, is all of that. So that is 8, and that's greater than the target. So what we want to do is now we want to remove this. L is on this index. So what we're going to do is we're going to say current sum minus equal to nums L. So it's just taking away nums L from current sum, and we're going to progress L by 1. All right. But something we have to also consider here is where are we updating min length? We have to think about that. So what we can say is, well, while current sum greater than or equal to target, we know that if the sum is greater than or equal to the target, then like it's a valid subarray. Although maybe it's not the minimum length, this is a valid subarray if this is true, right? So what we want to do is basically every time we pass through the while loop, we can really just update it. We don't have to check to like make sure it's like the smallest subarray or anything like that. We can just continually keep updating the value for min length. So min length we'll say is the minimum between min length and. Now let's imagine this, okay? Let's say L is 0 and R is 1, and that's the smallest subarray. So let's say this is the smallest subarray. Let's say it's like 5, right? Let's say the target's like 5. The smallest subarray in this case would be this. I mean, I guess actually no, that's right. This is the smallest subarray. So in that case, our length, in this case, R is 1 and L is 0. So the way that we find the length of a sliding window is we could say R minus L plus 1, because R is 1 minus L is 0 plus 1 altogether is 2. So that would be the length of this. So we could say that this is min length, and then we could have R minus L plus 1. Okay. Now I think this should probably work at this point. So yeah, essentially, here, let's just submit it just to make sure that everything's working smoothly in this. Or actually, let's run first. Test case does not have enough input argument. Expected. Oh wait, oh sorry, this is a test case that I made. Oh, oops. I was like, I've never seen that response before. Let's see. Oh, beautiful. Okay, nice. Okay, so yeah, so essentially this value, if the program finds a single subarray that's greater than the target, it will automatically update this. But if they can't even find one, like for instance, if it's like, if there's like a case where it's like 1,000, and then it's just this, right? All ones. I guess there's this case. Yeah, this case does a good enough job. Like essentially, if you go through this, you're gonna see that all of these ones, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 ones here. They add up to 8. They're not reaching the target, so the output here is 0. So basically, all I said is if you don't find like another sum that's greater than or equal to the target, then that means that this doesn't even change. So that means this is going to stay as the float of being infinity, right? And if that's the case, then we're going to return 0. Otherwise, we're just going to return whatever value it's been updated to. Then here, we're simply just working our way through the list. So all that's happening is we're starting here, and then we check the number, and then we go here. And then we add this number, and then L is still here. And this number is still smaller. Well, I guess now I've changed the test case, but originally this test case was 7, right? 7. Let's see. So this should hopefully still run. Yeah, okay. So this is 2 and 3, and then what's going to happen is it's still not less, so it's just going to add another. Eventually it's going to get here, okay? And then what's going to happen is the current sum now is 8, okay? So since it's 8, what we're going to do is we're going to say that the min length is the minimum between these two. In that case, we're going to get 4. Okay, I'm just going to write down here, we're going to get 4, okay? That's our min length, okay, right here. Then what we're going to do is we're going to subtract this number, and we're going to move L up here. So now we have this, okay? This is exactly how I explained it when I did it the first time. And now this, however, is not going to satisfy that. So we have to move and add the next term again, which is right here, okay? And then what happens here is now we have 10, so much larger than 7. So now we're going to, once again, min length equals to the minimum. Really what's happening here is we're looking at the minimum between 4 and 4. So we're just going to set it to 4, and it's still going to stay the same. And then we're going to remove this. So now we're going to have 1, 2, and 4. And now we have 7. And now we're comparing, this is 4, and this is 3, and so it's going to take the minimum, which is 3, so now this is 3. And then what we have is this. And now we're removing the left again, so now we have 2 and a 4, and now this is too little, so we have to add the last term, which is up here. And then what we do is now we have 9, so 9 is greater. So now we're comparing 3 and 3 here. The length here is 3, that's that, and then this is our previous iteration. And then it's still going to stay as 3, so this is 3 from before actually. and now essentially we just remove the last term, and now we have 4 and 3, and then what we realize is that it's still equal. It just barely satisfies that bit of criteria, and then what ends up happening is now we have a 3, and the new array is 2. And so this is what our min length is going to be, and then we're going to remove this, and then we're going to have 3, and 3 is not greater than the target. And so because of that, the for loop completely comes to an end, and our return value is going to be 2, which is from this subarray right here. So yeah, that's pretty much this problem. Let's give it a submission and see how it looks. Beautiful. Nice. Okay. So yeah, that's me walking through this problem, minimum size subarray sum, medium problem, sliding window. I hope you guys enjoyed, and I hope you guys learned something. If you guys think there's a better way to solve this problem, please let me know down in the comments below, and I will see you in the next one. Bye-bye.